You've been doing equations for a long time, many years. You probably haven't done them with matrices. So this is where what we have is 4 times a matrix minus another matrix equals another matrix. So what we're going to do is we're going to solve for this matrix. And I'm telling you that A is that one and B is that one. But I'm going to tell you that putting the numbers in is actually making it harder at first. Let's simplify this in a way. So I'm going to do this 4x minus A is equal to B. If I didn't know they were matrices and I was solving for x, I would just move everything to the other side. So I'm going to do that first. I'm going to add A. So I have 4x equals either B plus A or A plus B. With adding, it doesn't matter. If this was minus A, I'd have to put it afterwards and do B minus A. Or negative A plus B, but it's easier to do it minus. Now I'm going to divide by 4. And I have x equals either A plus B over 4, or I can also do it as 1/4 A plus B. Either of those would work. I find this one a little easier to work with, so I'm going to leave it that way for now. Okay, so now what I'm going to do is I'm going to do x equals 1/4, and I'm going to now put these matrices in there to add. 4 and 1, negative 7 and 5, plus 2 and 7, 3 and negative 5. So, order of operations, we'll do what's inside the parentheses before we multiply. And when you're adding, you simply match up the elements to add them. So that means 4 plus 2 is a 6, 1 plus 7 is an 8, negative 7 plus 3 is a negative 4, yep, and 5 take away 5 is a 0. I'll let you catch up to there. This is the scalar multiplication where you just take that and multiply to each one of these elements inside there. So x 1/4 times 6 is 6 over 4, but 6 over 4 is actually 3 over 2. 8 over 4 is a 2. Negative 4 over 4 is a negative 1, and 0 times it is just 0. That is our x. We have just solved it. I left a good deal of space on this page because I also want to show you how to check it. So what we're going to do is we're going to put it in here and we're actually going to check it. So on the bottom part, half, let's go ahead and put this in here. Minus, so I'm going to use this and I'm going to put that into the x. I'm going to put the A in. 4, 1, negative 7, 5. 7, 3, and negative 5. So what we want now is, if we put that x in, is it true, is it actually so that this side will equal that? Well, let's do it. Order of operations, let's multiply before we subtract. So 4 times 3 over 2 is going to be a 6. 4 times 2 is an 8. 4 times negative 1. And 4 times 0. When you subtract, it's the same thing as the adding, you just do minus. 6 minus 4, that's 2. 8 minus 1 is a 7. Negative 4 minus a negative, or plus 7, looks like a 3. And 0 take away 5 is a negative 5. Oh, except for my not being able to write a 5, it looks like these two are indeed equal. So, yes, they are indeed equal. That checks it. Because multiplying and then subtracting, I get the same thing. So that's how you would solve a matrix equation where you only have adding or subtracting or scalar multiplying. We'll have another one, an inverse one later, or another point where you end up doing multiplying of them. But first, let's take a look. This second page is just like the other one, except it's a plus, so you'd bring that over as B minus A. I will let you do this one if you want to for practice. You don't have to, but I'll leave it for you, and you can do it if you want, and on Friday I will have it posted with the correct answer. Let's take a look at page 3. For page 3, these first two things I have is a reminder of what you need to know in order to multiply matrices. Okay? So if I want to multiply A times B, it matters what they look like, what their dimensions are. So when you write out their dimensions, the key thing is that the columns of the first one and the rows of the second one, they have to match. See, they're both 3s. Because those match, that means, yes, you can indeed multiply these two matrices. But the result, here's the interesting thing, the resulting matrix after you multiply it is going to use the two outside numbers. The resulting matrix is going to be a 4 by 2 matrix. So these two numbers match, and these two numbers give you the dimensions of the new matrix. Take a look at the second one, and I look at the second number of the A and the first number of the B, and they don't match. Because they don't match, that means you can't multiply. So just can't do it. You'd say cannot be multiplied. Right? So no solution. No solution would be a good way to say that. So let's look at B. We'll do a couple of these. B and C on here. So B, this one's nice and easy. This one's a 2 by 2. And this one's a 2 by 2. And so you have 2 and 2. These match. And therefore the result is going to be a 2 by 2. So let's go over how to do it. And I have a method that I'll show you here. I know the result's going to be a 2 by 2. So I'm going to make a nice big 2 by 2 on the page. And I'm going to put this and set it up so I have 4 little quadrants. I'm going to do the work that I need to get this number. I'm going to have this space to work it out, and this one, and this one, and this one, because I know the result of this is supposed to be a 2 by 2 like this. So I need the 4 numbers. Okay. So here's the pattern. Some of you have already looked through this and it makes sense to you, but if you haven't, and even if you have, let's review it. This one here, it's on the top row, and it's in the first column. So from here, you're going to use the top row numbers, and you're going to use the first column numbers. And I'm going to multiply and add. So I'm going to do 1 times -5 plus -2 times -7. Write those down and then look at the pattern. I chose the 1 and the -5 because they were the first ones each. The 1 and the -5, so the top number of both. And I multiply it. I add to it the other two numbers being multiplied. The second one here going sideways and the second one going down. So it's the first one for each and the second one for each being added. So that gives me -5 plus up, that becomes a positive 14. 14 take away 5 is a 9. So that means in this spot, I'm now going to have a 9, because I can write the 9 now. For this one, I'm going to use this pattern where it's the top row, but now we're in the second column. So I'm still going to use the top row, but now I'm going to use this second column, the 6 and the 8. But I'm going to do the numbers the same way. The first numbers for both of them, the 1 times the 6, plus the next two numbers, the second one and the second one. Even though this one's going down, that's because it's in the column, but I'll do -2 times 8. So I'll do parentheses around negative. So 1 times 6 is 6. -2 times 8 is plus a -16, or just 6 minus 16, which gives you a -10. So I can put a -10 here now. So I'm going to put the results up on that. For the bottom ones, think about the pattern. We're now on the bottom row, so from the first matrix, we're going to use the bottom row. We're not going to use 1 and -2 anymore because we're not in the top row. We're going to use the 3 and the -4 for the bottom row. But we're in the first column, so we're going to use the bottom row here, but we're still going to use the first column here. So I'm going to use 3, -4, and so I'm going to write this out. It's 3 and -4, and it's the -5 and the -7. So I'm using that 2 and that 2. So I'll still do the 3 times the negative 5, the first one and the first one. So it's 3 times negative 5 plus the second one here and the second one here. So going over and down, plus negative 4 and negative 7. So that's negative 15 plus 28. 28 minus 15 is 13. So I'm going to have a 13 here. Okay, you see how that pattern is. I am going to show the next answer in a second, but I want you to go ahead and do this pattern. Now that you see how to do it, you see which ones to use, which row, which column, figure out the fourth one yourself, if you haven't already. If you did it with the 3 and the negative 4 from the bottom and the 6 and the 8 from the second column, you should have a negative 14. Cool. That negative 14 here. That's how you multiply them. Let's look at the next page, because this one was a 2 by 2. It was pretty obvious you could multiply it. It's not so obvious here. So let's look at this one and that one. And it looks weird. It looks like you probably can't do it. But follow the thing about rows and columns. This one has 2 rows and it has 3 columns. This one has 3 rows and it has 1 column. Rows come before columns. So because these match, we can say, yes, we can do it. The result is going to be a 2 by 1. That means it's going to have 2 rows and only 1 column. So I can set up here a sort of big one. I'm going to have 2 rows here, this row and only 1 column. So what I'm going to do is, for the top one, it's going to be this row times this column. And now you see why it's not a second column. This row against this column, this row against, oh, there's no more columns. So that means we can only do it 1 time for the top. And then on the bottom, it'll be the bottom row and 1 column. So there's only 1 column, so we'll only get 1 answer. And because there's 3 of them, we're just going to do first one, second ones, third ones. So that's a 1 times 7 plus 2 times negative 8 plus 3 times 9. So that's a 7 minus 16 plus a 27. And then that will add up to, let's see, 34, let's see, 11. I think that's going to be 18. 7, let me see, 34, I think that's an 18. Okay, yep. Check it with my answer, but a number of ways to think of it. So I did this and thought it was 11. 11 plus 7 is 18. That's probably the easiest one. Now we'll do with these and that. These are all negatives, so it gives you negative practice. Negative 4 times 7 plus negative 5 times negative 8 plus negative 6 times 9. So it's negative 28 plus 40 minus 54. So negative 78, taking the 40 away, and then 50, 67, 82. Negative 82 plus 40 is a negative 42. So that means our answer would be 18 and negative 42, and that's it. In a way, it's a relatively easier one to do because there's less multiplying and adding to do. That's where some of them, they come up different. But once you verify that these two are equal, then you can use these to set yourself up to get the right dimensions and then figure it out. But remember that pattern, row times column. And top row for the top ones, and bottom row for the bottom ones, and then the columns as they belong. The one underneath it, I'll let you practice on your own, and I'll have those steps all written out when we get to when I post it in Google Classroom.